We need to find the voltage V0 for this circuit. First I will do it since there are two voltages or voltage sources, I will use principle of superposition to do it. So I will ignore this voltage source for the time being, and if I ignore this one, becomes like short circuit. It was 2 volt though, to remember. So this one looks like an inverting amplifier. So basically V0 over Vi is minus Rf over Ri R1. So V0 will be minus Rf, which is 10 kilo ohms, Ry is 4 kilo ohms, and V0 Vi is 3. So that is 2.5 here times 3, that's negative 7.5 volts. And again, if I keep this one here, this 2 volt voltage source here, plus minus 2 volt there, and erase this one, get rid of this one. So now I am considering the 2 volt one. So now it is a non-inverting amplifier, so the output over input, or gain is like 1 plus Rf over R1, and Rf is 10 and this is 4, so V0 is becoming 1 plus 2.5 times, of course, this is 2 here now, so 3.5 into 2, which is 7 volt. So in order to find the total voltage, I have to add these two values. So output will be, of course, if I say this is VO1 and this is VO2, like VO1 VO2 will be VO1 plus VO2, and if I add them, minus 7.5 plus 7, which gives me 0.5 volts. So that's fine. This is one way of doing it. There is another way of doing it, which I will do now. So I will now observe that we know that for an op-amp Vi is equal to V2, they are the same. Now V2, if I say V2 is the non-inverting amplifier input, that is 2 volts, so Vi will also be 2 volts. So I will point out here, this voltage is, which is V1, and that is 2 volts, and this is Vi. So the current goes this way. There is no current that is going to the input, so current flows in that direction. And if I say the current as I, from this point to this point, I can write the current as V1 minus Vi over 4. So V1 is 2 minus Vi is 3 over 4. So that is 1/4. Similarly, from this point to this point, I can say the same current I can write also in terms of these two voltages from applying Ohm's law. So V1 minus V0 over 10 kilo ohms, because that's the resistance here. So V1 is 2, because this one is 2, so this point is 2, so this point will also be 2. So 2 minus V0 is 10. So of course 1/4 will be 10, 1/4 will be equals to 10, so not 10, sorry, 2 minus V0, 10. So this is becoming 10 over 2 minus V0, just equating this one and this one. So this is 2.5 here, this is 2 here, 2 here, and this is V0 here. So if I rearrange, V0 is becoming minus 0.5 volt. It is exactly the same as before the other method. So this method can be applied without going into principal superposition because of using the op-amp properties. So we get the same result anyway.